Hi friends, in this video we are going to take a look at matrices and also the various types of matrices we have. Okay, so the first step, let us consider a set of simultaneous equation. Considering a set of simultaneous equations, so in this simultaneous equation, I'm going to bring out all the coefficients of these variables. You understand? And I'm bringing out all the coefficients of these variables here. I have 2, 3 and 5. I'm having followed by 4, 2 and 7, having 3, 4 and also what? And also 2. Can you see it now? So these coefficients, I'm going to enclose them in the brackets. So I'm going to enclose them in the brackets. Enclosing these coefficients in the brackets, look at it. So I'm having what's this? This actually was a matrices, right? So in this case now, the coefficients of x, y, z present in this equation, I've enclosed them inside within a bracket now. So we can now say that a matrix, look at it, a matrix is a system, or we say is a systematic, systematic arrangement of numbers, systematic arrangement of numbers in a rectangular array. So in rows and column rather. So bounded by a bracket. Can you see it now? So you can simply say a matrix is a systematic arrangement of number in a rectangular array in row and also column bounded by what? By a bracket, right? So in this case now, if you take a look at these matrices, the type of matrices here, don't forget we are having this is a row and this is a column. So in this case now, we are having what? We are having 3 row and also 3 column. So this is what? This is 3 by 3 matrix. Can you see now? So this is what? 3 by 3 matrix. Now let's take a look at the various type of matrices that we have. So the first one I'm having here is what? Is row matrix. If we are talking about row matrix, is a type of matrix that has to deal with what? To deal with only one row and also what? And any number of column. So it's a type of matrix that has to do with what? Any one row, any just has to do with just a row and any number of column. So let me just write down the derivation and I'm going to give you what? The example to it. So under row matrix, you can say if a matrix has only what? Only one row and any number of column. So in this case now, if a matrix has only one row and any number of column, it is said to what? It is known as what? It is called row matrix. Example, let's say we have what? Just only one row. Let's say we have the case of what? Of 7, 3, 4, 9. Can you see what? This is a row. This is what we call one row, and it has what? Any number of column. So this is actually what? A row what? A row matrix. So in the second case, in the case of what? Of column matrix. Column matrix now, a matrix is said to be column if it is having what? One column. Can you see that? One column and also what? Any number of row. Just like this, reverse of what? Of this. So now in this case, a matrix, so having one column and any number of rows is what? Is called a column matrix. So in this case now, a matrix having one column and also any number of rows is said to be a column matrix. E.g., that's example. If you have something like 7, let me use this one. 7, 3, 4, and arranged in a column. This is called a column matrices. Can you see it now? So now let's move to the next one. That's zero matrices. That's no matrix or what, or zero what, or zero matrix. So in this case now, any matrix in which all the elements are zero, any matrices in which all the elements they are zero is known as what? Is called no matrix or what, or zero matrix. You understand now? So any matrix in which all the elements are zero is called what? No matrix or what? Or zero matrix. Example, let's say we have something like, let me use 0 0 0 0 0 0, yeah, 0 0 0. So this is actually what? An example of what? Of zero matrices. So any matrix in which all the elements are what? At zero, it is known as what? No matrix or what? Or zero matrix. Now let's move to the next one. The next one I'm having here is what? Is actually the square matrix. According to square matrix, a matrix is just a type of matrices in which the numbers of row is also the same thing, exactly the same with what? With the number of column. Well, what I actually mean is that a matrix is said to what? A matrix is said to be a what? A square matrix if and only if the number of rows is equal the number of what? Is equal the number of what? Is equal to actually is equal the number of what? Of columns. Of column, yeah. Can you see it? So a square matrix is just a type of matrix in which what? The number of rows is also the same thing as what? As number of what? Of column. For example, let's say we are having what? We are having, let me just give us such example. Let's say we are having something like 2 4 6 8. Can you see that? So in this is square what? Matrices, because the number of what? Of column of row is also the same as what? As number of what? Of column. Can you see it now? So now let's check another case of what? Of matrix that we have here. Now in this case, the one I'm having here with me is what? Is diagonal matrices. What is diagonal matrices? Diagonal matrices is also what? A type of square matrix. Is a matrix is what? A square matrix is also called what? Diagonal matrices. You understand that? A square matrix is called a diagonal matrix. So if all the non-diagonal what? Non-diagonal, let me say, elements are zero, that's what we call what? Diagonal what? Matrices. Diagonal matrix also what? Is also a square matrix if the non-diagonal element is equal to what? Is zero. So now in this case now, I will say a square matrix. A square matrix is what? Is called a diagonal matrix if all its non-diagonal elements are zero. So yeah, a square matrix is what? Is just called a diagonal matrix if all its non-diagonal elements are what? Are zero. For example, let's say I'm having something like this: 1 0 0 0 4 1 and 0 0 2. Can you see it now? So now in this case, can you see this is a diagonal. This is diagonal. This is what we call what? Diagonal what? Elements. Let's say this one is actually zero. This is what we call what? A diagonal what? Elements. So in this case, what actually happens is that, can you see all its non-diagonal elements that are equals to what? Equals to zero. So this type of matrices is called a diagonal matrix. A diagonal matrix is a type of square matrix. It's also called what? A square matrix, in which the what? All its non-diagonal elements, they are what? They are zero. Then let's check the identity matrices. Under this identity matrices is also called what? A unity what? Matrices. A unit matrix rather. It's also called what? A unit matrix. So under identity matrix, a square matrix is called identity matrices if all its diagonal elements are what? Are unity, are in units, are if all its diagonal elements are what? Are equal. Can you see that? And all its non-diagonal elements is equal to what? 0. Now under identity, we just say a square matrix is called identity matrix if all the diagonal elements are unity. If all the diagonal elements are unity and non-diagonal elements are 0. That's just the case of what? Of identity. For example, let's say we have what? Is identity just exactly like this, but the only difference is that in this place we are going to have what? Identity what? Element. Let me just use this case. We are having 1 0 0 0 1 0 0 0 0 1. Can you see that all these diagonal elements they are what? They are the same. They are what? They are unity. And all these non-diagonal elements that are equals to what? Equals to 0. So that's what we call identity matrices. So under this transpose now, let's move to transpose. So under transpose matrix, let's say if we are given a what? A matrix A, or we are given a particular type of matrices, a 3x3 matrices, a 2x2 matrices, and the thing is that we rearrange the corresponding rows and also what? Column. Can you see that? So the new type of matrices that is formed is called what? A transpose what? Matrices. What I'm actually saying is that if you are given a particular matrices, maybe like in particular matrices A or B, something like that, and that matrices, the role of the matrice, and also the column of the matrix, we interchange it. It is actually called transpose. So now in this case, I'll just give the definition as, let's say, if a given matrix A, if in a given matrix A, actually, let me put in, if in a given matrix A, we interchange the rows, and we interchange the row and the corresponding matrix. So the new matrix formed, or the new matrix obtained, let me use obtained rather. The new matrix obtained is called transpose, of the matrix A. It's called transpose of what? Of matrix A. And that's just it. Let me just give us an example. Let's say we are given what? Example. We are given matrix A to be equals to 1 2 3 4 8 2 9 0 1. Let's say we are given what? A particular matrix. This is matrix what? Matrix A. And I wanted to form a transpose what? Matrix. This is how it's going to happen. Here, this will be equals to, this is the row. I'm going to interchange this. I will turn the row to what? To column. So I will be having 1 2 3 4 8 2 9 0 1. Can you see it now? So this particular matrix, this new matrix that is formed from this is called what? It's called a transpose what? Matrices. This is matrix A, and this is what? This is A transpose. That's what it could be. Like transpose matrix can be represented as what? As either A prime or A transpose. You can represent this, you can denote them like what? Like this. It can be denoted like what? As A prime or what? Or A transpose. So the interchange of the row and also the column of this matrix is known as transpose of what? Of the matrices. So now let's check the last one I'm having here, which is what? Orthogonal matrices. What is orthogonal matrices? A matrix is said to be orthogonal. Like a square matrix Is also called what? Is also called an orthogonal matrix if the product of the matrix A, if the product of a matrix A and the transpose of matrix A is an identity matrices. I'll come again. Orthogonal matrix is like, let me just say, a square matrix is called an orthogonal matrix if the product of the matrix A and its transpose that is, and the transpose of matrix A is an identity matrix, right? So I'm going to put it down. So I'm having a square matrix is called an orthogonal matrix if the product of the matrix A of matrix A and the transpose of matrix A, the transpose of matrix A is an identity matrix. So a square matrix, according to orthogonal, a square matrix is what is called an orthogonal matrix. An orthogonal matrix if the product of the matrix A and the transpose of matrix A is an identity matrix. For example, let's say we are having the product of what the question the explanation says if the product of what of A matrix A and the transpose is equals to what is equals to an identity matrices. Can you see it now? So it is what? It is orthogonal. A matrix is what? Is said to be orthogonal. And also under this orthogonal matrix, you need to know that if magnitude of A is equals to what? 1, that means matrix what? Matrix A is proper. Okay, so that's just it. There are still more examples I'm going to explain in a separate videos. There are still a lot of examples under what matrix.